Now the topic is basic principle of remote sensing. Basically, the foundation of remote sensing technology is based on the measurement and interpretation of pattern of the reflected electromagnetic radiation. Electromagnetic radiation is the dynamic form of energy, and this energy transmitted across the space in the forms of wave in the speed of light, and EMR interact to the atmosphere, and 34% of EMR reflected back to the space as a albedo, and rest of the EMR interact with the Earth surfaces and Earth atmosphere, and the Earth surface and the Earth material interact with the EMR and in the forms of absorption, reflection, and the transmission. The next step is the EMR re-radiated by the Earth's surface. The various objects of the Earth's surface have a different reflectant. So, EMR reflected by the Earth's surface, and that reflected EMR reached to the artificial satellite, and artificial satellite sends the reflected EMR through the device. That device is known as sensor. Basically, there are two types of sensor: active sensor and the passive sensor. Passive sensor detect the reflected electromagnetic radiation which are natural source, that is the normal source or natural source, that is the EMR from the suns. But the active sensor emits a pulse of energy to detect the reflected EMR. Uh, we can take an example of active sensor as a X-ray machine. X-ray machine normally send a signal to the body, and that signal re-radiated back to the machine, just like that. So through the active sensor or passive sensor, reflected EMR recorded by the artificial satellite. Here, in the cases of reflected, absolute zero is very relevant. Absolute zero is an infinity cold scale. Absolute zero is a thermometric scale. Okay, if you want to convert into the centigrade, it is minus 273 degrees centigrade. It's normally described by the unit of Kelvin. The object of the Earth's surface, the temperature higher than the absolute zero or the Kelvin scale, can re-radiate the EMR. That EMR reflected and detected by the sensor. It may be active sensor or the passive sensor. Therefore, third step of remote sensing is to sense through the active sensor or the passive sensor, that is reflected EMR from the Earth's surface. Next step is that this sensing process very minutely performed through the multispectral scanner. This multispectral scanner is nothing but the use of electromagnetic spectrum through the visible and non-visible band to detect the intensity, to detect the type, to detect the brightness of EMR. So, fourth step is used multispectral scanner to scan to detect the specific configuration of reflected EMR. We can take an example for the Landsat series or Landsat satellites of NASA. There are thematic mapper scanner and thematic mapper scanner composition of 9 spectral band. So more spectral band is more useful, provides more precise and more detailed information about the Earth's surfaces. In multispectral scanner, in multispectral band, we can use the visible part of the band, that is RGB, even the infrared and the near infrared, short wave infrared, even the panchromatic band, and for the Landsat 7 and 8 we can use the NASA can use the band 9 too. So more spectral band provides more accurate, more detailed information about the Earth observation, about the Earth surfaces. After recording the all information, all details of reflected EMR by the active sensor or the passive sensor through the several bands, that after completion of that process, a signal sent through the charge coupled device on the ground controlling point, and ground controlling point through the charge coupled device collect the signal. After collecting the signal, they store the data on the form of pixel rather on the form of raster data set. Raster represent the data as a cell or the grid matrix. It's an arrangement of the dataset with the particular row and column. Each row and column represent the information about the Earth's surfaces, and each the grid or the pixel always described with the numerical value, that is called the DN value or the digital signature. So after the getting the information in a raster form, and with the coding system and decoding system with the help of the numerical value, that is the DN value, next step is convert the raster dataset to a vector dataset. Next step is to convert the raster data to the vector dataset. Vector data normally represented by the points, line, and polygon. After the conversion of raster data to the vector data, we can get that kind of information. Okay, after conversion, we have to go for the false color composition, rather standard false color composition. Let's have a look. This is a raster data structure. We get the information about the Earth's surface through the satellite in the form of raster dataset. And after the decoding of raster dataset, we can get the vector dataset. And after getting the vector dataset, we can convert the vector dataset to the false color composition, as standard false color composition, and the satellite image. After the conversion of raster dataset to vector dataset, rather after converted the pixel data to the line, points, and polygon, last and final stage is create the image with the standard false color composition. False color composition is an artificially generated color image in which blue, green, and red colors are assigned to the wavelength region to which they do not belong in nature or the natural spectral band. In standard false color composition, blue is assigned to green band, green is assigned to red band, and red band assigned into infrared band. Here, to easier representation, you can take the help, that is blue is assigned as green band, green is assigned to red band, and red band assigned to infrared band. Most of the cases in standard false color composition, infrared band, shortwave infrared, and mid-infrared band are intensively used in standard false color composition. Let's have a look at the standard false color composition. In the cases of standard false color composition, near infrared band, green band, and red band are intensively used. And at end, from the combination of all band and superimposition of all band, we can get the final version of the satellite imagery.